Okay, in Lesson 1, continuation of Lesson 1 actually is called Fact Families Part 1. And the question is that we're asking is, what is a fact family? Well, an example of this would be, how about if I have the numbers 4, 5, and 9. Now if I add the first two of them, we notice that 4 plus 5 is equal to 9. Now I can also use those same digits and I can come up with another true statement or true equation. For example, I could take 9 minus 4 and that's equal to 5. And notice that these are the same digits. In both these problems I have the digit 4, I have the 5, and I have the 9. And what this is called a fact family because the addition in this one, I can use subtraction in this one to undo that addition. So in other words, fact families are really a relationship among addition and subtraction, and further down the line, multiplication and division are inverse operations. And I'm just going to write that term, okay, inverse operations, because that's kind of an important term as we continue in math. So inverse operations, and I'm going to write my S below there. Inverse operations simply means that one undoes the other. For example, addition and subtraction are inverse operations because one undoes the other. Now, continuing with inverse operations, or in other words, this relationship among two problems or two sets of digits, let's talk about other facts that we can write, or in other words, other fact families. Now, for example, here I can not only write that 4 plus 5 equals 9, how could I use those same digits to make another true equation for addition? Well, I could simply reverse, and I'm going to put that in a different color. I can switch these two around. So when I'm adding two numbers and I switch the order, that has a certain term or a certain name, and that's called the commutative property. And the commutative property says that the order you add two numbers doesn't make a difference because they're still going to add up to the same sum or total. So for example, I can simply switch these around. So 5 plus 4 is equal to 9. And again, these would be a fact family because I'm using the same digits to create two equations or two problems. Now let's take a look at this subtraction one over here. How could I kind of switch some digits around to make another subtraction problem? Well, one thing you notice is I can't just simply switch these two digits around because there's not a commutative property for subtraction, because in subtraction order does make a difference. But I can modify this a little bit and make another subtraction problem. For example, I can actually switch these two digits. Same thing as what I did over here. You kind of see a little pattern there. So I could say that 9 minus 5 is equal to 4, which is a true statement. So all we're saying here is that a fact family is a combination of digits to form other equations using the same digits. And you'll kind of get a better hang of this as we go along. So let's take a look at our first example. All right, in example 1, it says, arrange the numbers in the following addition fact to form another addition fact and two subtraction facts. So really there's three things they want us to do. They want us to form another addition fact, and they want us to form two other subtraction facts. So we're going to make up what we call a fact family. So first of all, let's do the addition fact. So how can I take this equation right here, which is 11 plus 14 equals 25, which is true, right? Because we know that 11 plus 14 does add up to 25. Now how can I form another fact family, or in other words, another addition fact? Well, remember in addition, the order that we add two numbers, doesn't make a difference. So I can actually switch those around, and I could write 14 plus 11 is equal to 25. and that's my other addition fact. So I've taken care of this one right there. Now let's write two subtraction facts. Now let's see if we can remember how I did that on the previous slide. Let's see, I can't just I can't switch the 14 and 11 and come up with a subtraction thing or subtraction equation necessarily. But what I can do is I can take the bigger number, which is 25, and they want a subtraction fact, right? So I can subtract one of these other numbers. So I could subtract the 14, and what do you think is going to happen with this fact family? Remember, all these are equations that are called a fact family. They have the same 3 digits in them. Well, 25 minus 14 then would be equal to 11. Okay? So that's one subtraction fact. Now, how can I take this subtraction fact and make another true subtraction fact using those same 3 digits? Remember, I can't just switch these around. And really, that was what I was trying to get to up there. Well, but I could take the 25, leave it, and switch these around, right? So I could say 25 minus 11 is equal to 14. Now I've created one other addition fact and 2 other subtraction facts. Let's do one more example. And notice this subtraction problem's written a little differently. It's written top to bottom and not side to side, like on example 1 where that addition fact was written side to side. Now here they want us to rearrange the numbers in the subtraction fact to form another subtraction fact and 2 addition facts. So what I'm going to do first here is I'm going to underline what they want us to do. Let's see, they want us to form another subtraction fact, and they want us to form 2 addition facts. Now this is very similar to example 1. Let's see if we can go through this. Now to form another addition fact, I know that there's not a commutative property, and I'm going to erase that here because I'm going to just back up. I'm getting a little ahead of myself. I cannot just switch these around. I can't switch the 6 and 11 around and say that 6 minus 11 is equal to 5, because actually it's not. I can't switch the order in subtraction. So in other words, there's not a commutative property for subtraction. Order does make a difference with the subtraction, so I can't do that. So I'm going to erase that. But what I can do is I can switch the, and I'm going to erase this part too so we don't get that confused here. I can switch these around. So another subtraction fact would be 11 minus the 5 is equal to 6. And notice I switched the 6 and the 5 around with subtraction. So now I have another subtraction fact. Now I want 2 addition facts. Well, I'm thinking to myself, let's see, what 2 numbers could I add together and get the other number? Remember, we're working with a fact family. We're working with the digits 5, 6, and 11. So I have to use those. So which of those 2 numbers could I add together and get the other one? Well, the pattern that you're going to see is usually you can add the 2 smaller numbers together to get the bigger number, right? So there's an addition fact. Now I can use the commutative property for addition, which says that the order I'm adding does not make a difference because 5 plus 6 is the same thing as 6 plus 5 equals the 11. So now I've created my subtraction fact, which I wrote up and down, and really I should write these 2 addition facts that way since the original problem was written up and down. Really, it's not going to be a difference. If you left it like that, that's fine. But I also could have written it as 5 plus 6 equals 11, and then the 6 plus 5 equals 11, and I'm done. So our topic today was called fact families, which is a relationship among 3 digits where I can come up with subtraction and addition facts. And we also tied in the concept or the idea of inverse operations, meaning that addition undoes subtraction and vice versa. And down the line, we're going to see that multiplication undoes division and vice versa.